Are we live? Hello all, a very warm welcome to today's webinar on One Health, Links in the Spread of Antibiotic Resistance. I am Dr. Donna and I will be the moderator for the webinar. This webinar is being conducted as part of the Preventive, Risk Management and Prevention of Antibiotics Resistance project. Preventive is a 3-year project co-funded by the Erasmus Plus program of the European Commission. The vision of the project is a future where every individual is aware of the antibiotic resistance and is empowered with the right education to address the issue of ABR. One Health is an approach that recognizes that the health of the people is closely related to animal health and the shared environment. It is not a new concept, but it has gained momentum in recent years. In order to address the rising threat of the antibiotic resistance, we require a One Health approach. Why? Because antibiotic resistance does not recognize geographic boundaries or human-animal borders. In this regard, I am pleased to welcome today's speaker, Dr. B. Sunil, a very special guest from College of Veterinary and Animal Sciences, Thrissur, Kerala. Dr. Sunil completed his Masters in Veterinary Sciences and has a PhD in Veterinary Public Health. Currently, he serves as a professor in Veterinary Public Health. He has 28 years of experience in teaching and research. His area of research expertise lies in zoonosis, food safety and management, AMR, and One Health. He has completed 23 research projects and has 88 publications, 5 books, and 1 patent to his credit. He was instrumental in establishing the first One Health Center in India, the Center for One Health Education, Advocacy, Research and Training. He was also an expert member of One Health Kerala Antimicrobial Resistance Strategic Action Plan team. After attending this webinar, the attendees will be able to gain insight on antibiotic resistance, its mechanism and management. They will also be able to understand the various links in the spread of antibiotic resistance. They will get insights into the concept of One Health. Before I hand over the mic to Dr. B. Sunil, I have a few instructions to the audience. The webinar is being conducted on the Zoom and we are directly streaming it to the YouTube. If you have a question to our speaker, please type your question in the chat box that will be either present below the video or towards the side of the video. While typing a question, please begin by typing hashtag AskPreventive so that we will understand that these are the questions to be addressed. We will try to address all the questions at the end of the session and we are keeping aside 15 minutes for the same. Please use this opportunity to enhance your knowledge. I would also like to add that this webinar is being recorded. So whoever is not able to attend the live session will be able to listen to it later. The session will be posted on the official website of Preventive, www.preventive.in, and also on the social media pages of the project like Facebook, Twitter, and LinkedIn. At last, we would like to encourage you to share today's webinar within your social networks. So without any further ado, I would like to welcome our speaker. Dr. B. Sunil, over to you, sir.
Thank you, Dr. Donna. Am I audible now?
Yes, sir.
Okay. I'll be sharing the screen.
Yeah.
Has that come up?
Yes, sir.
Okay. Okay, thank you very much. I would like to thank Prevented, the group which is working on the risk management and prevention of antimicrobial resistance, a project which is co-funded by Erasmus. Dr. Donna and her associates and the team behind that. in giving me this wonderful opportunity to share my experiences and interact with you all by sharing some of my experiences, talking to you about what is One Health and what are the different links in spread of antibiotic resistance. Now, what you're going to learn is something about antibiotic resistance, what it is all about, what is the complex link in this entire matrix? Is it so complex or is it subtle? How do we manage this resistance? And ultimately, we'll wind up with the concept of One Health. Now, antibiotics, as we all know, are substances which are produced by microorganisms which selectively suppresses the growth or kills other microorganisms at a very low concentration or the dose at which it is applied. Now, there are two terms which are concurrently used. One is the word antibiotics. You could also be hearing the term antimicrobials. So, is there a difference between these two terms? When you talk of antibiotics, you are narrowing down the spectrum, coming to the drugs which are specifically used against the bacteria. Whereas when you're talking of antimicrobials, it is basically including the antibiotics which are in use. It could use, you could be looking at the sanitizers which you are using, and several other drugs or chemicals which are used to kill the microbes. So that is the basic difference between the usage of the term antibiotics and antimicrobials. Now, antibiotics have been classified. I'm not going to the details of this based on the structure. There have been looking at it. If you look at it, you could find drugs like sulfonamides, the group sulfonamides, quinolones, beta-lactam group of antibiotics, tetracyclines, aminoglycosides, and a lot many classifications. So depending upon the structure, depending upon the mode of action, the type of antibiotics have been classified into different types. Now let us have a quick look at the mechanism of action of these drugs. Some of these drugs, like for example, the beta lactams, they act on the cell wall of the microbe. Like for example, the penicillins, cephalosporins, monobactams, carbapenems, and all this group of antibiotics, they act on the cell wall. Now, there is yet another group which acts on the plasma membrane of the organisms. Like, for example, the polymyxins, which include the polymyxin B, the now famous colistin group, the lipopeptides, and all these groups. They act on the membrane of the organisms, thus destroying the organisms. There is another group which act on the ribosomes of the organisms. Like, for example, your aminoglycosides, tetracyclines, and all those things. They act on the ribosomal part of the bacteria. You have another group which attacks the metabolic pathway of the microorganisms. Like, for example, the folic acid synthesis, which is being inhibited. Like, for example, your sulfonamides, the sulfones, trimethoprims, and all those group of drugs. You have yet another group which attacks the DNA synthesis or the RNA synthesis. Like, for example, your fluoroquinones, ciprofloxacin, levofloxacin, and those group of drugs, they act on the DNA synthesis as such. The rifampicins act on the RNA synthesis. So as you can see, you have a varied mechanism of action of these drugs on the organisms. Now, let us look at some of the problems that arise with the use of antibiotics. Now, these antibiotics are actually a wonder drug. You know, decades back when it was developed, it had saved millions of people from infections, especially during the war, during the injury, during the world wars, and all those things. The people who were injured were saved by the use of this miracle drug. So it was at that point of time turned a miracle drug. But then its usage comes with lot of side effects. Now, what are the effects of this? The other side of this miracle drug, its usage could lead to toxicity. Like, for example, some of these drugs could be hepatotoxic. Hepatotoxic means it is toxic to the liver, or it could be nephrotoxic, toxic to the kidney. So it could be toxic to different organs in the body as such. So that is toxicity. So that is toxicity. Now it could be hypersensitive. That means the person who is taking these drugs could develop reactions to the drug. That is why when we take antibiotics, usually the doctors will test you for hypersensitive reactions. That is one aspect. Then there could be super infections. Now this is a very, very interesting phenomenon, the super infection stuff, the superinfection is a second type of infection which is superimposed on an earlier one. That means you are having an infection and then you are taking an antibiotic to treat that particular infection. But what happens is that that particular pathogen might be destroyed, which is causing the infection, but there may be several other pathogens which are lying in the same system without causing much problems. But these pathogens could be resistant. When these pathogens are resistant, they start rearing its head up and causing the problems from their own side. So this is what is known as super infection. That means you treat a person for a particular type of infection. That particular infection is controlled by the antibiotic, but when you have a resistant pathogen inside that particular framework, that again starts rearing its head up and causing the infection. So this is a phenomenon which is usually seen due, especially as an example, it is overgrowth of Clostridium difficile, which you see following treatment with any broad spectrum antibiotic. So some of the organisms you do not know. So you treat for an particular disease or if target a particular organism, you have some other organism causing the disease. So that is super infection stuff. You have nutritional deficiencies. Now, many of these antibiotics, that is why, when you are giving the antibiotics, it's already coming up with the big complexes and other supplementations which come up with your antibiotic prescription. Like for example, when you are being prescribed antibiotics, you are told that your fat content in your diet should be low because the absorption could be very less. So whenever this gut flora, that is when you are taking the antibiotic and the flora inside your gut is disturbed or your intestine is disturbed, the production of vitamins like vitamin K and your B complex vitamins are hindered. Especially you can see that in that is cephalosporins, which affect the absorption of vitamin B and K from the intestine. Another example you can take, like when you're using gentamicin. Gentamicin causes calciuria, that is the calcium will be seen in the urine. That is, you have lower amount of calcium. That is hypocalcemia. That is lower amount of calcium. So there is depletion of calcium and depletion of magnesium in the treatment with certain drugs like, for example, gentamicin. So that is nutritional deficiency. The other aspect is with regard to drug resistance. Now, this is what we are talking about. So it is not that the entire thing is something new. Whenever, this bacteria and all those things are all wonderful organisms in the sense, whenever you are thinking of some mechanism to evade them or bypass them or destroy them, they are two steps up front. That is the mechanism which they have. So we need to be extremely cautious in the way we use these drugs against the microbes. So we need to see to it that the drug resistance is minimized or managed, because ultimately we cannot do away with resistance phenomenon. It is already inbuilt in the organisms or the bacteria. Now let us look at what is this antimicrobial resistance or antibiotic resistance. Now, microorganisms not inhibited by usually achievable concentration of this agent with a normal dosage schedule. That is, whenever there is a particular dosage prescribed for a particular organism. That is, at this particular dosage, if you give it for this particular days, the organism will be completely inhibited or eliminated. But when this doesn't happen, that is, you are giving the normal dosage of the drug, but it is unable to inhibit the particular organism, then that creates a phenomenon of, or this phenomenon of antimicrobial resistance. I hope you are understanding this concept. So when this happens, what happens is that whenever you are giving a drug, another drug, that particular drug will target a particular organism and kill that. But when you have resistant organism in that particular system, that will start flaring up. Just as I have talked about super infection, the same thing happens here. And then what you have at the end is more of resistant organisms than the sensitive organisms. Now, this threatens the human health, animal health, the economy, especially national and also global security. So antimicrobial resistance has a lot of connections to that. So that is why we say that one of the most important driving force is the injudicious use of the antimicrobials or the drugs in human beings as well as in the animal health sector. The World Health Organization has considered AMR to be the top 10 threats to the global health, because when you don't have antibiotics to treat, then you are at loss of words. Now, what do you do next? You don't have a system to treat these organisms. Then where do you go? That is why this has come as a top priority for WHO. Not only for WHO, even for Animal Health Organization, International Day Epizooticus, the World Health Organization in Animal Health, and also the Food and Agricultural Organization. All of these three considers AMR to be of top priority. Now, these wonderful organisms, how do they develop this resistance? Now, you may be thinking that only when you start using these drugs, they have developed these genes and all those things. That is not the case. These things are inherent in them. Now, one of the ways is these organisms could degrade the enzyme which is present there. That is, the antibiotic degrading enzymes could be present in these organisms, and these could degrade the antibiotic as and when it enters the microorganisms, so that the impact of the drug is minimal. Another way is the altering of this antibiotic enzymes. These are all controlled by genes. So when the antibiotic altering enzymes are there, the antibiotic structure itself gets altered and it will no longer be able to function inside that particular organism. The other interesting phenomenon is what is known as the efflux pump mechanism. Now, efflux pump works just like the motor wherein you are pumping out water from a well. As and when the antibiotic enters the organism, this pump starts up and pushes the entire antibiotic outside the cell. So these are all wonderful mechanisms which the organisms have developed. You can see a tiny microbe like this having so intricate mechanisms within that to sustain itself. Now, this is all about sustainability. I think we need to underline the word sustainability because of that. Because you, me, the organisms, everybody wants to sustain ourselves. So what is the mechanism that we have developed? So look at this beautiful, intricate mechanisms this organisms have got. Now let's a little bit go back in time. Now I have already mentioned that these are all miracle drugs which have been developed. And I have said that the moment a antibiotic has been developed or it has been deployed, the next moment the process of resistance is on. Like, for example, you look at the sulfonamides. They were deployed in 1930s to 40s, but by 40s, the resistance have developed. If you look at penicillin, deployed in around 40s, by around 45, complete resistance have been developed. Chloramphenicol deployed by around 45, and by around 50 to 55 they have developed the resistance, so on and so forth. And if you come later on, the later drugs, you see the number of drugs are less. The reason is the emergence of new antibiotics have also ceased as we are moving along. There could be several reasons for that. We will not discuss that now, because That is left to the industry, because now they know that you spend so much of time and money and funding on developing a new drug, but the organisms are so clever that the next moment they start developing the resistance, and all the funds which they have utilized for a new drug goes waste. So maybe probably the pharma industry has also thought that, okay, there is no point in developing any further drugs because we are not going to get back what we have invested in. Okay. Now let us look at the impact this resistance is creating. Around 0.7 million people are dying or losing the battle to AMR per year, and around 10 million have been projected to die by around 2050. Now, these are all projections, but then these are all scary figures if you look at it. And it is AMR itself is killing more people than probably cancer and road traffic accidents. So AMR is coming on right on top. And with regard to the economic projections, by 2015, AMR is going to decrease the GDP of nations by 2 to 3.5 percentage, and a fall in livestock by around 3 to 8 percentage. We have all witnessed in COVID how the GDP and the economy has been drastically impacted world over, not only in a particular country, world over. Now, this is a lesson for all of us. And this has ultimately, it will going to cost around $100 trillion to the world. Now, these are all some of the impacts which this could bring about. Now, this is because of the large scale consumption of antibiotics, both in human as well as in animals. And globally, if you look at it, there has been a 60 to 65% increase in the consumption globally, and India right on top with around 103% increase. China around 70 to 80% increase, and Pakistan 65% increase. So globally, the antibiotic consumption is increasing, and this is due to several factors, because as nations develop, their healthcare systems develop, and hence the consumption of antibiotics could also probably be increasing. Now, this is the very important and a very complex matrix that we are going to learn today. That is the link in antimicrobial resistance. Now, you can see the complete arrows being filled up here and there, and that is bringing in the complexity to the situations. On the right side, you have the humans, and on the left side, you have the food animals. We just take those two. On the right side, the human, and the left side, you have the human food animals. On the middle, we could bring up that aquaculture and the rest of the environmental aspects. All right. Now, carefully have a look at that. You on top, you have the aquaculture system. Let us take it from that side, from the top. Aquaculture. Aquaculture brings along with it usage of several chemicals and drugs, which could find its way into the rivers and streams, into the soil, and possibly to the wildlife. So that is one system which you have to very seriously be looking at. Again, go right, you have various waste treatment plants. And when these waste treatment plants are not properly run, and the waste are running off into the soil or probably getting an access into wildlife, that brings this resistance into these two parts again. You have your industrial, again on the right side, you have the industrial and the household antimicrobial chemicals. The pharma companies which are producing this antibiotics, if they are unable to properly treat it, and then that waste gets into it, again it gets into the soil and probably the rivers and streams. From the treatment plants, it could get into the vegetables, fruits, cereals. Again, the handling and consumption of that could create problems to human beings. Let us leave that at that. Come to the left side. You have the food animals. Definitely, just like human beings, animals also need antibiotics for treatment. But that will come to at a separate thing. But that is one of the aspects. So from the water, like for example, if rivers and streams are contaminated with this resistant organisms, and through the drinking water, the animals could be getting that. From the animals, through the processing units, meat, again, the human beings are going to get these resistance. So this resistance pattern, spreading of this resistance pattern is a highly complex mechanism. And we need to bring complexity into the way we are looking at it. and then simplify that. The entire system is so complex. That is why we need a systems approach to take care of this entire phenomenon. Now, let us look at the AMR in a global health system. Now, the hypothesis is that novel mechanisms of resistance start in a given place and then spread worldwide. Now, because of this, you can see the way in which our COVID is spreading. So, even if the resistance is to start in a particular corner of the world, this is definitely going to spread worldwide. And bacteria carrying these resistant genes have been found in various habitats, including the wild animals, natural ecosystems, and even in archived soils. And there has been an increase in the abundance of AMR genes ever since, that is, let us say, the 1940s as the landmark year wherein we have started this antibiotic usage. Since then, the number of genes have also increased. Now, recently, these resistance genes have also been found in the gut flora of people who are living in the isolated areas and untouched by modern civilization and not exposed to antibiotic therapies also. That is why I said the genes are present not because the antibiotics have come in. The resistance genes are already there. It is only that when these have been exposed to this, they start functioning. So that is the concept which you have in mind with regard to the AMR, the global health. Now, that is why you say these are driven by the humankind, anthropoid drivers of antibiotic resistance. Now, look at it. Is it actually the human beings who are driving these resistance or the bacteria themselves? The bacteria have certainly the mechanism to respond to whatever threats they have. That is, the response is in the form of their resistance genes, which is present in nature inside them long before the antibiotics have been started to be used in therapy. The spread of AMR in human pathogens is a recent event. It is evolutionary. That is after the drug development. That is a spread of this resistance. But the presence of the gene has always been there long before the use of antibiotics. Now, this is why we say that these are anthropoid driven evolution. That is, when you start putting in the antibiotics, the gene starts functioning. Now, let us look at some of the aspects with regard to antibiotic use in human beings. Now, human antibiotic consumption has been increasing, as we have already seen, and this increase is more in low and middle income countries because these economies are going to develop and their access to health services are also going to improve, and hence the more usage of this antibiotics. Now, these have also been, the use of this has also been linked to more usage to lower sanitation and poor hygiene also. So when you look at our sustainable developmental goals, which has been put forward by UN, the quality of the water, the quality and safety of the food, the quality of the oceans, the land, everything is connected to proper health. So this is how you say that, when you have a good system of the basic foundation of your good food, water, and your shelter systems, then definitely your antibiotic usage is going to decrease. Otherwise, when you are living in a shabby conditions with poor quality of water and food and living conditions, definitely your antibiotic usage is going to improve or increase. Now, because of this, it has been predicted that there is going to be a further 200% increase of usage of antibiotics by 2030. And antibiotics, especially in humans as well as in animals, which has been consumed in the absence of a proper medical supervision. That is, you have a common cold, you have a fever, you directly go and take a antibiotic shot on your own. So this is a very common phenomenon in countries like India, and this is a very, very serious cause for the development of resistance. Another as very important aspect with regard to this is the presence of illegitimate or your poor quality antibiotics. And India, incidentally, is one of the leading manufacturers and use of this substandard drugs, especially the substandard antibiotics. And half of this consumed antibiotics in the human beings get eliminated unchanged from the body via the feces or urine. So now you can imagine now what happens when half of those is getting eliminated from the body via feces and urine. The fact is, this gets into the sewage system and becomes a runoff into your rivers or water bodies, leading to the uh, increase in the resistance pattern we have already seen. Now, another aspect is the antibiotics which have been discharged through the effluent plants. They are high enough to cause genotoxic alterations and modify the bacterial strain. So, genetic changes itself could occur in the bacterial strain from this high concentration of the antibiotics through the effluents. And development of rapidly degraded antibiotics, advanced water treatment systems could possibly reduce this concentration of antibiotics and reduce the selection pressure towards AMR. But these are all extremely costly things, and that is why in country like India, these have not been made a priority as such. Now, let us look at antibiotic usage in animals. Now, around two-thirds of this antibiotic usage, overall antibiotic usage, is for animal production. 131,000 tons of antibiotics being used globally for food animal production. And this might rise to 2 lakh tons by around 2030. So this is a huge increase because the population is increasing. You want the food security aspect to be met. There is going to be an intensive agriculture which is going to take place, intensive animal rearing systems in poor conditions. Definitely, this is the reason why the antibiotic is going to increase, especially in the usage in animal production. Now, let us look at the Indian scenario with regard to the use of antibiotics in animals. The largest consumer of antibiotics in animal is India, the fourth largest after China, US, and Brazil. And this is going to increase, this consumption rate is going to increase by around 2030. And along with this resistance bacteria, antibiotic residues have also been reported. Residues are the metabolites of these antibiotics after degradation in the body, which is present in the food products, like, for example, your meat, your milk, and other animal products. Now, residues are also of concern because handling these products could have the transmission of these residues into your hands, into your other environment, wherein the bacteria could also be present. So you are giving a lower dose contact for these organisms, leading to the chances for your resistance mechanisms to be developed in the particular organisms. So residues are also of concern. But then the residue also comes up. There are also standards for also all these food products for different antibiotics and drugs. And the OIE standards are also available. And as far as India is concerned, the Food Safety and Standards Authority is taking care of this by bringing out standards in India. We have looked into the fact that the excess use of antibiotics has been curtailed in animal products for export. But no guidelines are currently in effect for domestic consumption in India. So that is a concern. So that is why the FSSA has come up with is coming up with those guidelines in animal products. Now, why these antimicrobial agents are used in animals? Some of them are used as growth promoters in animals. Now, when those antibiotics are used, the intestinal mucosa gets thinned and the absorption rate is high. So the growth promotion is there. As a prophylactic, that is, it is heard, you don't want a particular infection to completely wipe off your stock, so you give it as a prophylactic. It is also given in household pets for prophylaxis, for pest control, and other purposes. So antibiotic, and also for treating of particular diseases. So growth promotion is a particular factor which to be taken care of, and now antibiotic for growth promotion has been completely banned. Now let us look at the pharma industries. Now India is one of the leading producers of this pharmacy, leading producers. Uh, and if you look, there are two reports which has come up which is really having significance, because one of the pharmaceutical plants, the level of ciprofloxacin which has been discharged into the water bodies has been so huge. Ciprofloxacin level in excess of almost 50 kg per day, especially in Hyderabad. Now, this is a very, very, very irresponsible way of disposing this drugs into the water bodies, which will have very severe repercussions. Now, because when you are discharging it into a river or a water body, it is not confined to a particular place. This is going to have downstream effect to those places this water is going to be carried. So this is a very, very extremely alarming situations, and the pharma industries need to be more responsible to these facts. Not only this, fluoroquinolones and sulfonamides, they are drugs which are again being seen in the water bodies. And whenever these water bodies are polluted, as I have said, the downstream areas, the rivers, ponds, and ultimately the seawater is the one which is going to get contaminated. So adequate treatment of wastewater as per the developed countries. Now the standards have been developed, and if these standards are met and the wastewater is treated, this could probably decrease the associated risk with this. But this is again, as I have said, the wastewater treatment, especially for drugs and all these things, is a costly affair. It needs regular monitoring, and hence it is of a low priority objective, especially for the industry, because when the price and the cost is increasing, the priority is less. But ultimate cost of this irresponsible discharge has to be worked out. Now, the another important aspect is the climate effect of this antibiotic resistance. The climate change is another area which is going to bring in lot of changes, be it emergence of zoonotic diseases, other infectious diseases, or modification of the natural ecosystems. All those things are going to bring lot of changes in the way the not only the antibiotics but the emergence of disease is going to take place from now on. Now, global warming, it's a biological it's going to be a very, very serious issue, because it is going to alter the way in which microbes, human beings, animals, and vector species are going to interact. Because you could see that, every ecosystem has got a particular flora and fauna in that. When a temperature changes, maybe some particular species will move out, and that space could be occupied by some other species. So this brings in lot of changes. So this has effect not only in disease transmission, but also very important role in AMR transmission. Effects like El Nino possibly modifies the ocean currents. There is when this is the ocean current is probably modified, you can imagine there is going to be a different manner in which the distribution of this pathogens, which could possibly be carrying this resistant genes to different parts of the world. Again, natural disasters, floods and hurricane becoming very common nowadays. It could either increase or decrease the pathogens. And along with that, the transmission of this resistance genes could also be altered. So as you can see, the contribution of these phenomenon in dissemination of AMR is extremely critical. And probably we have not been looking at this aspect till now, because we have been looking at the host, the pathogen, and other things. The environmental part of this, we have hardly given much notice to. So I think it is high time that we start looking into it. Now, another area is probably the livestock discards, like, for example, the animal excreta, which could contaminate the environment directly with the resistant organisms, the agriculture manure and the sludge again, and the aquaculture. Aquaculture is gaining in big way, and the usage of antibiotics in aquaculture, there are stringent regulations with regard to that. But whenever these residues have also been reported from shrimps in India, and this water which is being emptied or is being fed to certain other water bodies can again transmit the problem of antimicrobial resistance. Now, let us come to the preventive measures. We'll quickly go through that. Now, how can we do that? It needs a thorough understanding of the concept of resistance. Now, people used to ask, who is resistant? Is the animal resistant to the drug or the human beings resistant to the drug? It is not that way. It is not the animal who is resistant, it is the pathogen who is resistant, isn't it? The pathogen which is present in either the animal or the human being who is resistant to the particular drug. So understanding is very important. And for this, a global action plan has been formulated. Now, as I have said, WHO plays a major role in that. Along with that, you have the World Organization for Animal Health and the Food and Agricultural Organization. So these three organizations have come together to formulate what is known as the Global Action Plan. And based on this global action plan, the every nation has also developed their own national action plan. India too has a national action plan on antimicrobial resistance, and Kerala being the first state to develop this policy on Kerala antimicrobial resistance strategic action plan based on the One Health. So after Kerala, a few other states, like for example, I think Madhya Pradesh and Delhi has also come up with an action plan to combat this resistance pattern. So preventive measures, the first and foremost thing is you're responsible. And that is why you say stewardship, antimicrobial resistance stewardship. What is the responsibility of the industry? We have talked of the pharma industry. The responsibility of the industry to curb uh, the way in which this resistance can be controlled by the proper treatment and the quality of the drug which they produce. Now, what happens when the quality of the drug is reduced? When the quality of the drug is reduced, you are actually giving a sub-therapeutic level of the particular drug to the particular patient, whether it is an animal or a human being. So this is a chance for the organisms to develop resistance. So such things should be taken care of. And you can have a look at this Kerala Strategic Action Plan. It is available in the net. You can have a look at like how different stakeholders are incorporated into this plan as such. Now, let us come to the concept of One Health. Now, the concept of One Health is nothing but a collaborative, multi-sectoral, and transdisciplinary approach. Because people have started understanding that a problem, simple problem, cannot be possibly solved by one particular sector alone. Let us again take this example of our AMR with regard to this. Now, let us say our human sector is taking all the measures to see to it that the AMR in human setting is reduced. All the measures are being taken. Now, what happens if the other sectors are not taken into consideration? So, whatever steps are taken in the human sector is going to be a waste because you already have no particular methods to control this resistance problem in either the environment or in the livestock sector. That is why we say it should be collaborative, multi-sectoral, transdisciplinary approach, working at local, regional, national, and global levels with the goal of achieving optimal health outcomes, recognizing the interconnection between people, animal, plants, and their shared environment. So this is a very complex definition. I'll make it very simple. You need to develop this collaborative network globally. For example, we can say that when you say globally, you have our organizations like WHO, OIE, the World Organization for Animal Health, and FAO coming together. They develop this global policy on that. Coming to the country wise, you have a policy, national level. It could come down to the state level, to the district level, to even the panchayat level. So this is how this is being carried about. Now, if you look at our on the right side, that small picture which you have, under the One Health umbrella, you could possibly include the public health people, the environmental people, the veterinary and human medical people, your molecular and microbiology people, ecologists, wildlife, the economists, statisticians, very important. So the different groups of people who can play a very important role in finding solution to a problem. So depending upon the problem, you start defining which group of people you want to get into the One Health umbrella. If it is AMR, you have a set of stakeholders in that, get all those stakeholders into that. If it is zoonotic disease control, you have a zoonotic disease program, you have an umbrella for that. So you need to develop that based upon the problem which is at hand. Now, who makes this approach? Who is going to be involved? As I've already said, it is a joint approach wherein you are dealing with public health, animal health, plant health, or environmental health. This is with regard, I've just put in with regard to our AMR aspect, because same microbes are infecting human beings and animals. It is the same microbes which could be present in the environment, the soil, the water, or probably it is the animals and human beings are also sharing the same ecosystem. So everything is the same. It is in the same ecosystem that everybody are living in. So that is why this entire concept works out beautifully. So that is why we say the efforts by just one sector cannot prevent or eliminate the problem. Let us take a disease like, for example, you want to prevent, let us say, a particular disease like brucellosis in human beings. You have all the control measures in human beings, but no control measures in the livestock sector. It's not going to work out. So you definitely need to have a parallel program running in the livestock sector. And then you have a collaborative approach, which will completely prevent this. So think these are just examples which I am giving. That is just for to make you understand this concept of One Health, how it works out. Now, another some of the areas wherein this One Health concept could be utilized, as I have said, in case of emerging, re-emerging, endemic zoonosis, AMR, food safety. So all these are all the areas wherein you could apply this concept of One Health, and this has been envisaged by the WHO, FAO, OIE, and UNICEF, which clearly embraces other disciplines. It is not a question of one discipline alone taking care of that. Other domains, including environmental and the ecosystem health, social sciences, ecology, wildlife, land use, and biodiversity. When I'm going into the land use, I have not touched on that, because land use pattern is one particular aspect which is playing a very critical role both in case of emergence and re-emergence of many of these diseases. So whenever you have this emergence and re-emergence, it is also bringing with that the concept, problem of microbial resistance with that. So that is why land use pattern and biodiversity is also very critical in case of management of all these conditions. Now let us look at some of the One Health actions for reducing this AMR burden before we wind up. Now, let us look at the therapeutic approaches. You need to have a policy for antibiotic use, which was hitherto absent, but now we have a policy for antibiotic use, considering the local burden of AMR in a particular region. Development of new antibiotics for animal use only, but that may not always be a possibility. But now WHO and OIE has come up with critically important antibiotics. Now, antibiotics which are going to be used for human beings are going to be separated out. Antibiotics which are going to be used for animals are going to be different. So you have critically important antibiotics for humans and critically important antibiotics for animal beings. You could think of other methods, therapeutic approaches, like, for example, the use of bacteriophages against bacteriopathogens, vaccines against the pathogens, and different management aspects. So therapeutic approaches has to be modified so that you take control over the resistance pattern from developing. Now, reduction pressure can be reduced by proper surveillance. You do not know actually the consumption of antibiotics, consumption in hospital, consumption in community, consumption in agriculture. Now these data are slowly coming up, but previously there was no such data available. So surveillance gives you an idea like how much of the consumption is there, and then you can take proper appropriate measures. Control and supervision of sale of antibiotics, for that means it has to be by prescription. Now, there has been some laws which are coming up by the drug controller with regard to the use of antibiotics in human beings. So similar aspects are going to come up for even in case of animal prescriptions. So local guidelines for prescription, considering the AMR burden and its release in the environment, and surveillance of antibiotic residues and pollution in the water and food, development of degradable antibiotics, use of non-antibiotic compounds for prophylaxis. So you could probably use for prophylaxis other non-antibiotic compounds so that resistance doesn't develop to the antibiotics. And novel systems in animal productions, focusing on reduction of antibiotic use. You cannot completely curtail the antibiotics from animal production systems, because you cannot have production systems without antibiotics. Definitely that might be needed, because otherwise you need to get that to that level of hygiene and welfare to have a system wherein you are absolutely not going to use any antibiotics. So it is at what level you are going to use initially and considerably reduce it over a point of time.
Sir, if you could,
Yes, please.
sir,
Ah,
if you could fasten the thing, like
yes, yes.
it's already.
I'm just coming up. I'm coming up. I'm coming. I'm just coming to the end of this.
Okay,
You
sir.
also need to have the One Health surveillance systems. One Health surveillance system is, it's a system wherein you are saying that you're not having one particular sector having the surveillance system. You have the surveillance joint surveillance system, including the livestock, animal husbandry, wildlife, or probably you take your environmental and other ecological people also along with that. So that is one system which wherein you can think of. Now, these are some of the ways in which you could incorporate different disciplines into a common platform and then ultimately solve problems. It is not a question of AMR or zoonotic diseases or anything. For any problem, it is going to be multi-sectoral. It is already proven that no one sector can completely take care of a problem and come out with a solution. So that is why you have that One Health system for animals, man, and nature. The Kerala Veterinary and Animal Science University has come up with the Center for One Health Education, Advocacy, Research, and Training, the cohort, which is located at Wayanad. And this is the first center which we have developed with courses. We have courses, diploma courses, and certificate courses, which are available now on One Health. People from different streams can come in and join and then understand what this concept is all about. Now, the basic aspect is you need to spread the word about the One Health, the system, both in the animal sector, human sector, and the environment sector. Only then we'll be able to control many of the problems which are being faced by us, including AMR, zoonotic diseases, and other emerging and re-emerging diseases. Thank you very much for the time. I don't think I have overshot my time. Thank you very much, and thanks for the patient listening.
Thank you, sir. Sir, if you could please stop
Yeah,
sharing
I
the
have stopped.
screen. Thank you,
Yeah,
sir.
thank you.
So we have a lot of interesting questions, sir.
Yeah,
So if you
absolutely.
can we start with the
Yeah,
questions?
please, please.
So the first question was, could you please explain how antibiotics act as growth promoter in animals?
Yes, yeah, I didn't get you. I didn't get you.
Could you please explain a little bit in detail on
About what?
on how antibiotics are acting as growth promoters in
Growth promoters.
animals?
Okay, okay.
Yeah.
See, when the antibiotics are given in the feed as growth promoters, the intestinal mucosa gets thinned down. You have a normal intestinal mucosa that gets thinned up. Now, when that gets thinned up, the amount of absorption of the nutrients increases. So you have a better feed conversion efficiency in those animals. That is the concept. You're getting that point, I believe. But the problem here is the gut contains millions of microbes, isn't it? The gut of the animal contains millions of microbes. When you are giving a subtherapeutic level of a drug or an antibiotic as a promoter, that is going to seriously develop resistance in the entire microbiota within that gut. And that is going to be definitely excreted out. And that seriously impinges on the our problem with the resistance pattern. I think, is that clear?
Yes, sir.
Is that
Sir,
clear?
yes,
Yeah,
sir. In connection with the same question, I just want to
yeah,
ask one more.
yeah.
Like, if when we consume the meat or milk of animals treated with antibiotic,
Okay.
will that
Hmm.
affect the human health, or are the antibiotics just excreted out of the animal system?
See, antibiotics are always metabolized in the liver. It is only a very small percentage that might find its way into the meat. So whenever you have a meat, we have a system which is called as the use of the withdrawal period. So if you are treating animals for on antibiotics, it is usually after 72 hours that you start taking the, let us say for the milking purpose, you start taking the milk. So depending upon the drug, we have a different withdrawal periods. So after that withdrawal period, definitely the milk will be free of the residues. But if it is taken before that withdrawal period, definitely the residues will be found in the product. But with regard to meat, it is very, very less, because you need to get the thing from the liver and then it has to find its way into the meat, which is very, very less. Chances are very less. You got the point?
Yeah.
Yeah,
Yes, sir.
but the problem here is the farmers need to be compensated. You cannot ask the farmers, you just throw off that milk. Who is going to pay them for that? Now, that is the problem. I think you are getting the
Yes.
seriousness of the issue. Yeah.
Yes. Yes, sir.
Okay.
So,
Right.
so we have the next question here.
Hmm.
So during the presentation, you mentioned that the consumed
Yeah.
antibiotics are excreted through the human and animal feces
Yeah. Feces. Yeah.
into the environment. So,
Yeah.
are there any methods to treat these excreta
There
before
are
we?
methods for treating this, just like your effluent treatment for pharma industries. There are methods, but then these are all very extremely costly affairs,
Okay.
extremely costly. That is why you cannot simply have this in all the uh, households or for the corporation and other. You cannot do that. Maybe industry should be doing that as a priority. Maybe after that, when the cost of all these things comes down, probably we can think of that. But
Okay.
at present, our priority should be for pharma industry, which is producing the drug and then discharging the waste, rather than for treatment of this antibiotics in the
Okay. Sir.
feces or sewage.
Okay.
Because
So
you
then,
cannot take all these things together. You need to prioritize and then go one step at a time.
yeah. So,
Yeah.
we have a lot of questions and we are short of time, sir. So, one last question we are taking.
Okay.
Yeah. It's regarding the One Health concept, sir. So, do you feel like it's difficult to implement One Health concept because it involves all the disciplines, right? It involves the human health, animal health, environment, everything.
Okay. Fine.
Hello, sir. Sir, am I clear?
I was unable to hear your question.
Okay, so I will repeat the question once more,
Yeah,
sir.
please.
The One Health concept includes the human health, animal health, environment. It's like it's a whole, all the disciplines are coming under one umbrella, right?
Yeah.
So do you feel like implementation of any One Health concept in the field of AMR, will it be very difficult process?
See, the question is how it is implemented. Because as you know, in India, the concept is, every department, even you take any college, every department in a college work in silos. Maybe there will not be a connection between two departments. Now we are thinking of a complete sector getting connected. So you can look at the magnitude of the way in which it has to be done. So it is your attitude. So the positive attitude, your trust in people. If the two sectors, like for example, there is no trust between you and me, then you cannot have a positive communication in or a networking, isn't it? So
Yes,
there
sir.
need to be a lot of changes happening. That is why I said the awareness is the first and foremost thing which need to be brought out. So that is why we have started this course, so that more awareness, people become aware of what is this concept all about. When I was talking about this One Health in the different forums, people were asking me, see, why we are talking of One Health? Because, you already have, different sectors which are looking at it. I said, then if sectors are looking at it, why they are not connecting? You have, you go about your business, I'll go about my business.
Okay.
So there should be a priority, there should
Yeah.
be a priority. If I am looking at AMR from the livestock sector and you are looking at AMR from an environmental perspective, and somebody else is looking at AMR from your human side, and then we are connecting, exchanging data, having strong policies, framework, and proceeding on the same frame, you will be able to bring about much more changes than probably I am working alone, probably the other two people are left off. So for that, common platform is essential first. That is why I said there should be a One Health structure. Unless you have a One Health structure, because this is what we had, I was talking of a brainstorming session in the morning, uh, wherein they are going to bring out a One Health structure for the country first. So that you will have a One Health structure for the entire country. And then every state will have a structure of this One Health, wherein you are going to bring in different disciplines into that. Once this is done, the structure is there, then you start working out the modalities and prioritize like where you want to give thrust to initially, and then your research component and networking, surveillance, diagnostics, and rest of the things follows. So it's not
Okay.
that very easy as we think. It is very easy to say that, all the components come up and work together. I just give you an example, how far are our departments communicating with each other? How far are the people in the same department communicating with each other? These are all simple things. It is all more of communication, getting networked and getting collaborations. So that is how it is all done. So it's a very complex issue, but then I think we need to be at it.
Okay. Great, sir. So I'm sorry that I couldn't take up all the questions. Maybe the we preventive team will come out with one article regarding the One Health, covering all the enquiries that we got through
Okay,
the
that's
chat
great.
box. Yeah. So,
Yeah, that's
sir,
great.
we are concluding the session. Do you have any message to share with the audience?
Yeah, I think our audience are, most of them are students,
Yeah.
isn't it? Yeah.
Yes, sir. Yes,
I
sir.
think as far as I'm concerned, environment teaches us many things. Environment. Everything is everywhere. That's what I say. Everything is everywhere. And nature will select what is best for it. Nature knows how to select. So you start using, human beings start using all their different kinds of jugaad, we say in Hindi. Jugaad means, you working your magic around using all your intelligence. But definitely nature knows how to react to that. The patience of the nature is, extremely high. But that patience, don't allow that patience to run off. If the nature loses its patience, just like the climate change which we are witnessing again, then we are in trouble. So I think we human beings need to understand that. Give that space to nature always and work on that. Thank you very much.
That was a strong message, sir. Great. I hope all the audience enjoyed the session and did not face any technical error. We do apologize if someone faced any problem. As I said earlier, the recorded version of the webinar will be available on the website. So please do visit the Preventive website. Thank you, everyone. We appreciate you being here. Stay safe, stay healthy.
Thank you very much, Donna and your team.
Thank you, sir.
Shall I log out?
Sure, sir.
Yeah, thank you very much.
Thank you.